All right, so the next thing we're moving on to is chapter 10, which is binomial theorem. All right, so chapter 10, example 1 says, find 8 factorial divided by 6 factorial. Now, 8 factorial divided by 6 factorial is the same as saying 8 times 7 times 6 factorial over 6 factorial. 6 factorial cancels 6 factorial. So your answer is equal to 8 times 7, which is what, 56? The answer is 56. Example 2 is asking you to simplify n plus 1 factorial minus n minus 1 factorial. Now, first of all, n plus 1 factorial is n plus 1 times n times n minus 1 factorial minus n minus 1 factorial. Now, the common factor here, can you all see? The common factor here is what? N minus what? 1 factorial. So if I factor out the n minus 1 factorial, I'm going to have n minus 1 factorial, and inside the bracket I have n into n plus 1 minus 1. Inside the bracket, I'm going to have n squared plus n minus 1. And I don't think that that can be factorized. So I have n minus 1. And in the bracket, this is factorial. In the bracket, I have what? N squared plus n minus 1. So the simplification is n minus 1 factorial times n squared plus n minus 1. Example 3. Example 3 says express as a single fraction. Now, if you are adding or subtracting fractions and the denominators are different, you must find the LCM. You all might not see it now, but the LCM here is actually n plus 1 factorial. That's the LCM. Because both n plus 1 factorial and n can go into what? n plus 1 factorial. But let me try and make it more visible to you. This is 2n over n plus 1 times n factorial. N plus 1 factorial is the same as saying n plus 1 times n factorial plus n minus 1 over n factorial. So the LCM is n plus 1 times n factorial. Now, n plus 1 times n factorial into n plus 1 times n factorial is to 1. 1 times 2 is 2n. N factorial into n plus 1 times n factorial is n plus 1. So we have n minus 1 times n plus 1. So here we have in the numerator 2n plus n squared minus 1. When you multiply the sum and difference of the same two terms, your answer is the difference of the square of both terms. And this is over n plus 1 times n factorial. Simplifying in the numerator, I'm going to have n squared plus 2n minus 1, which I don't think can factorize. That can't be factorized. And down by the bottom, we have n plus 1 times n factorial, which is actually n plus 1 factorial. So at the bottom, we have n plus 1 factorial. We're told to simplify it, and that is what it simplifies to. Example 4. Example 4 is asking us to express as a single fraction. All right, so here the LCM is n plus 3 factorial. The LCM is n plus 3 factorial. So this is n plus 2 over n plus 3 multiplied by n plus 2 factorial, which is the same as saying what? N plus 3 factorial minus n over n plus 2 factorial. The LCM is n plus 3 factorial, which is the same as saying n plus 3 times n plus 2 factorial. So n plus 3 times n plus 2 factorial into n plus 3 times n plus 2 factorial is 1. 1 times n plus 2 is n plus 2 minus n plus 2 factorial into n plus 3 times n plus 2 factorials is n plus 3. So this is n times n plus 3. Simplifying the numerator, we get n plus 2 minus n squared minus 3n. This is over n plus 3 factorial. So simplifying, we have 2 minus 2n minus n squared all over n plus 3 factorial. Can that numerator be factorized? Let us see. No, I don't think it can be factorized. So since it can't be simplified any further, this is your answer. All right.